Hello students, we'll study about practical chemistry. So under practical chemistry, we'll study about identification of cations. The first cation, what you are going to study is ferrous ion, that is Fe2 plus ion. When a sodium hydroxide solution is added to ferrous sulfate solution, a dirty green precipitate of ferrous hydroxide is formed, which is insoluble in excess of sodium hydroxide solution. So you can see here, to the ferrous sulfate solution, sodium hydroxide solution is added, a dirty green precipitate is formed. When you add excess of sodium hydroxide, it is insoluble. The same test can be conducted with ammonium hydroxide solution. When ammonium hydroxide solution is added to ferrous sulfate solution, a dirty green precipitate of ferrous hydroxide is formed, which is insoluble in excess of ammonium hydroxide solution. So this is the experiment which shows that when ammonium hydroxide is added to ferrous sulfate solution, a dirty green precipitate is formed, which is insoluble in excess of sodium hydroxide solution. So this is the equation. FeSO4 plus 2 NaOH gives Na2SO4 plus FeOH twice. It's a dirty green precipitate. FeSO4 plus 2 NH4OH gives NH4 NH4 twice SO4 plus FeOH twice. The next ion which you are going to identify is ferric ion, Fe3 plus ion. So when sodium hydroxide solution is added to ferric chloride solution, a reddish brown PPT of ferric hydroxide is formed, which is insoluble in excess of sodium hydroxide solution. So you can see ferric sodium hydroxide solution and ferric chloride solution is added to it. You can see a reddish brown precipitate is formed. So when excess is added, the solution is insoluble. The precipitate is insoluble. When ammonium hydroxide solution is added to ferric chloride solution, you can see again a reddish brown PPT of ferric hydroxide is formed, which is also insoluble in excess of ammonium hydroxide solution. So here is the equation which indicates ferric chloride combining sodium hydroxide and with ammonium hydroxide giving ferric hydroxide as the precipitate, which is a reddish brown precipitate. The next ion is copper 2 plus ion, that is cuprous ion. So here again we'll test it with sodium hydroxide and ammonium hydroxide. When sodium hydroxide solution is added to copper sulfate solution, a pale blue PPT of copper hydroxide is formed, which is insoluble in excess of sodium hydroxide solution. You add more of sodium hydroxide solution, the copper 2 hydroxide is insoluble. When ammonium hydroxide solution is added to copper sulfate solution, you can see a pale blue precipitate is formed, and when you add excess of ammonium hydroxide solution, the PPT dissolves to form an inky blue solution of tetraamine copper sulfate. So here are the equations. The first equation is with sodium hydroxide giving sodium sulfate and copper 2 hydroxide, which is a pale blue precipitate. Copper sulfate plus ammonium hydroxide gives ammonium sulfate plus copper 2 hydroxide. When you take this precipitate and add excess of ammonium hydroxide, you get tetraamine copper sulfate and water. So this is tetraamine copper sulfate as the inky blue solution which is formed. The next cation is Ca2 plus ion, calcium ion. When sodium hydroxide solution is added to calcium chloride solution, a milky white PPT of calcium hydroxide is formed. You can see a milky white PPT, which is insoluble in excess of sodium hydroxide solution. With ammonium hydroxide solution, calcium chloride do not produce any precipitate. So there is no reaction shown here. It's only with calcium chloride and sodium hydroxide giving sodium chloride and calcium hydroxide, a milky white precipitate. Then the next ion is the zinc ion, Zn2 plus ion. So when sodium hydroxide solution is added to zinc sulfate solution, a gelatinous white precipitate is formed of zinc hydroxide, which is soluble in excess of sodium hydroxide. You can see it dissolves in excess of sodium hydroxide solution and forms a colorless solution of sodium zincate. Then again with ammonium hydroxide solution and zinc sulfate is added, you get again the same gelatinous white precipitate, and when you add excess of ammonium hydroxide, precipitate dissolves to form a colorless solution, that is tetraamine zinc sulfate solution. So here we have not shown you one more same diagram because in both the cases the zinc hydroxide is soluble. So with sodium hydroxide also it is soluble, with ammonium hydroxide also it is soluble. So finally you get a colorless solution. So with sodium hydroxide and also with zinc hydroxide. Here are the equations. Zinc sulfate with sodium hydroxide is sodium sulfate plus zinc hydroxide. So sodium sulfate plus ammonium hydroxide is zinc hydroxide, and when this is taken and added excess of ammonium hydroxide, you get tetraamine zinc sulfate and water. There's one more equation here, that is when zinc hydroxide to zinc hydroxide, when excess of sodium hydroxide is added, you get sodium zincate. The equation is not shown here. Then you have Pb2 plus ion, that is lead ion. When sodium hydroxide solution is added to lead nitrate solution, a chalky white precipitate is formed, that is PbOH twice, which is soluble in excess of sodium hydroxide solution to give a colorless solution of sodium plumbite. When ammonium hydroxide solution is added to lead nitrate solution, a chalky white precipitate of lead hydroxide is formed, which is insoluble in excess of ammonium hydroxide solution. So here is the equation with sodium hydroxide, lead nitrate gives sodium nitrate with lead 2 hydroxide, which is a chalky white precipitate. This chalky white precipitate, when excess of sodium hydroxide is formed, it forms sodium plumbite, that is a colorless solution. And lead nitrate with ammonium hydroxide gives ammonium nitrate and lead 2 hydroxide, which is chalky white precipitate, which is insoluble in excess of ammonium hydroxide solution. So these are some of the cations which you have to study for practical chemistry, and remember the color and their solubility. So the next we'll study about anions, and among cations these are the cations which you have to remember. Thank you, children.